Welcome back. In our last lesson, we introduced the idea of probability. Today, we're going to explore what is perhaps the single most important formula in the entire field, Bayes' theorem. It's a simple equation with profound implications for how AI learns. So, what is Bayes' theorem? Simply put, it's the mathematical rule for how to correctly update a belief when you are presented with new evidence. It is the formal logic of learning from experience. The best analogy is to think like a detective. A detective starts with an initial belief about a suspect, then they find a new clue, the evidence, and based on that clue, their belief about the suspect gets stronger or weaker. Bayes' theorem is the math behind that process. To do this, the theorem uses three key ingredients. First is the prior probability. This is what you believed before you saw any new evidence. Second is the likelihood. This asks, if my prior belief was true, how likely would I be to see this evidence? And third is the posterior probability. This is your new, updated belief after you've rationally combined your prior belief with the likelihood of the evidence. Let's use a famous example. Imagine a rare disease that only 1 in 100 people have. That's your prior belief. The chance is low. Now, there's a test that's 99% accurate. This is the likelihood. You take the test and it comes back positive. This is your evidence. So what's the probability you actually have the disease? Your intuition might scream 99%, but Bayes' theorem shows that the actual probability is much, much lower, because the extreme rarity of the disease is a very powerful prior belief that has to be overcome. This is absolutely critical for AI because it's a blueprint for machine learning. Many AI systems are Bayesian, meaning they use this theorem to learn. Your email spam filter is a perfect example. It starts with a prior belief that an incoming email is probably not spam. But then it sees evidence, like the word, lottery, or free. It uses Bayes' theorem to update its belief, and the posterior probability of the email being spam shoots way up. This way of thinking gives AI incredible power. It allows models to incorporate prior, existing knowledge, so they don't have to learn everything from scratch. It allows them to update their beliefs incrementally as they see more data, getting smarter over time. And it allows them to reason logically in the face of uncertainty, which is a hallmark of true intelligence. So, Bayes' theorem is much more than just a dry formula. It is a recipe for rational thought. It provides a formal method for our AI systems to change their minds based on data, which is the very heart of learning. In our next lesson, we will see how these ideas from probability are put into practice when we dive into the world of statistics.